Hello again, welcome back to China Manufacturing Decoded from the Sofeast Group. This is episode 204 now. Adrian hosting today, and Renaud's joining me to talk about handing over manufacturing. Hi, Renaud.
Hey Adrian, and hi everybody. Well, interesting topic today. It's actually not a simple one.
It's certainly not, but it's one that's going to affect a lot of businesses when they're trying to get their products manufactured. It's as simple as that, right? And
Hmm.
so hopefully we can kind of do it in a nutshell and do the topic justice in our usual sort of time frame. So to get started, I guess set the scene, Renaud. What the context of it is. I mean, you've been designing and developing a new product, perhaps, and I suppose let's focus on hard goods with, mechanical or maybe some electronic parts, because that's what we
Mhm.
normally specialize in for our customers. And you've got to the point where you need to start the process to get this into manufacturing. So you're going to hand over to a
Mhm.
manufacturer.
Right.
What's the motivation behind doing that, please?
Well, first, not everybody does that. Sometimes I see, some companies, sometimes in the US and Canada, they want to keep things very close to that to themselves. They want to keep the volumes low, and maybe the innovator who's been doing some of the design and development on a shoestring budget is going to start selling, one unit there, one unit there, and
Mm,
maybe they will get to 20 units a month and maybe 100 units a month. And maybe they're happy to manage that themselves with a lower margin because they're buying the parts in low volume in North America, and they would do the assembly and the testing themselves or with their family or their friends or whatever. And that model works for some people. And then think maybe niche B2B products that really respond to a business need, and they can set at a relatively high price and there's no competition, right? And they're happy to do it with a low volume, high margin, high price kind of approach. So that makes sense, right? Not
mm,
everybody has to pass things on to a manufacturer.
right.
If it's still a relatively simple product, and as I mentioned, that's fine. Some people do that. However, most of the people that we talk to, well, they are thinking, hey, no, no, no. We want the relatively low unit cost. We want the ability to have the margin while still being cost competitive on the market. And maybe,
Mm,
and 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 most people who develop new products that we talk to again, they are shooting for many thousands and tens of thousands and ideally hundreds of thousands of pieces to deliver to
mm,
the market, right? So they don't want to handle that in their garage. Uh, so
right.
um, so they at one point they have to pass that on to a manufacturing facility, and a
Mm,
manufacturing facility ideally will also contribute to maybe give some feedback on the product design, design for manufacturing, design for reliability, these kind of things, depending on the manufacturer's competencies. And the manufacturer will do the industrialization, the later phases of the new product introduction process, right?
mm,
So that it goes into mass production relatively smoothly, with a reasonable risk and cost profile, let's say, right? So the question is how to actually hand over that information to the manufacturer. It's
mm.
not just you find somebody on Alibaba and they speak good English. Okay, let me send you all the design files, and okay, let's just go into mass production. It's fine, right? That is really not something you want to do.
No, people do it. Sounds very risky. It is very
Right,
risky.
right. So the bad practice that's actually been going on, for a long time. It's very well known. It's something you should not do, is to have designers work on the product design, and then they say, okay, that's fine. We have prototype, it works, and here's the industrial design files. and we specified what it's supposed to look like, and then just send it over the wall. That's sort of the expression
Mm,
to the manufacturing guys. And sometimes that was done in in the 50s, in the 60s, in companies that has maybe the design studio co-located in the same place as the process engineers and the manufacturing people, right? And that was just
mm,
nuts. They would just say, okay, that's it. Your job is just to make it happen, and we don't want to hear about you, right? Just make it happen. Get to lunch
mm.
in 3 months. Just do it, right? So that really doesn't work for a
No.
number of reasons, and I think we discussed that in a previous episode about design for manufacturing. Basically, if you don't take into account the manufacturing process and also the testing process, if if you don't get a feedback from the manufacturing folks about how they're going to make it and can they actually do it as planned, what are the processes they're going to use, what are going to do to be the downsides, what are some alternatives, etc. But that you're going to run into a problem, right? Plus, sometimes maybe you design a product and it just can't be made. Sometimes we have people come to us and say, well, for example, the plastic enclosure, well, that's the way it's supposed to be. That's, the designer made it this way and it looks good. And we're like,
Mm,
well, even the best plastic shop in the world is not going to be able to make it with plastic injection molding. So what are you thinking of? You know, oh, well, the prototype, we did 3D printing and it went well. Yeah, right. But
yeah.
when you have two parts of a mold that come together, and even with all the sliders in the world and all the extra little things that you can do, this geometry. It's just not possible. All right. So you need
Mm,
to maybe make it into separate parts, whatever, cut it here. It's really important. Sometimes they have two parts that are nearly symmetrical. We're like, if you make it exactly symmetrical, then it's going to be much easier with just one mold. But if you have this and this and this that are, i- it's not really necessary once we understand the design intent, right? We understand design intent and we look at things and, okay, this is not really necessary. It could be a bit different, right? And they're like, yeah, yeah, totally. Okay, then we'll make that change and it's going to be you're going to save maybe $10,000 of investment in a mold right here. Oh, okay, well, let's make this change, right? Uh, and things are going to be faster and so on and so forth. So there's a lot to be said about design for manufacturing. It's not just about cost, or it's also about the quality level that you're looking for. For example,
mm,
another very typical example, people say, okay, for a metal part, we want it to be nicely finished like this, maybe with anodizing. And we're like, wait a minute, on a cast part, there's going to be porosity. So yeah, the quality issues are going to be, you know, a big problem. And if you give a standard to the metal supplier, once it's anodized, they will have to put aside and rework a lot of parts. It's not just rework, if there's too much porosity, they will have to remelt it and reprocess it. And that's going to push the cost up a lot, right? Plus, you're
mm,
going to still have not very nice quality anyway. So you got to change that. You got to think of something else, right? Or also comes to really understanding the use case, the use environment of the product. Well, it's going to be used there, maybe on a boat that goes on the ocean. Oh, okay, so it's an
mm,
extremely corrosive environment. I mean, is stainless steel is still going to be okay if it's outdoor all the time? What can you do? Put extra whatever powder coating and things like that, right? These are the questions that really need to be asked. The problem is you work on the architecture and you're like and the industrial design and so on, and then you have some people go into the details of the engineering design. Okay, and maybe it's people in your team, and maybe it's people in a design house, or maybe freelancers, maybe on Upwork or whatever. Okay, and you give them some milestones. You say, okay, I get to get this, and I get to have a functioning prototype, etc. And they get
Mm.
it's human nature. They get focused on, okay, that's the next step. I'm just going to focus on making it work, right? And maybe they don't ask all the questions, so you get to the point where, okay, it works, all right. But there's a lot of other questions that need to be asked. It's not just, does it work, does it not work? Is
Mm.
how are people going to use it? Is it really fit for the use case, the use environment? Okay, but also how is it going to be made, with what processes, and what's, what's the impact on cost? What's the impact on quality? What's the impact on the timing also? Certain things are much slower. How is it going to be tested, right? Sometimes you have or like, how is it going to be assembled? How's the person who assembles it going to know if it's placed the right way or not? Sometimes people have to reach out, um, under a product, they can't really see anything. They fumble a
Mm.
bit with their fingers. They have to push it in. There's no click or no feedback, clear feedback that it's nicely assembled, well in place. And okay, how are you going to inspect then? Well, once it's there, the only way to inspect it is actually to disassemble everything. So you can't inspect it, right? So how are you going to mistake profit? Um, these are the types of questions, and I'm forgetting some of them. I don't have the full checklist here in front of me, but
Right.
design for manufacturing, uh, it is often sometimes something that uh, is not taken into account by the people doing the engineering design, or they take
Mm.
some of it into account, but you still need a review by an external party. I mean, design reviews are extremely valuable, even from the start, especially on the architecture and so on. You need to have an experienced tech lead to look at it and provide some feedback and review it
Mm.
anyway. But it's very, very true also for DFM. Like, okay, so who's going to do the DFM? If you select an experienced contract manufacturer that has the people who can do that, well, then you can rely on them, because they're going to do the DFM based on their own processes and their own suppliers' processes and their experience and so on. If they are going to do the manufacturing,
Mm.
is good if they do the DFM review and they suggest some changes, and maybe the engineers who have done the design until then are going to do the changes, right? Or maybe the manufacturer's team is going to do some of the changes, right? But in any case, um, that is really, really, really very, very important, right? Um, Also reliability. I mean, very often we review something that a customer sends to us, and we're like, well, whoa, okay, there's going to be a lot of vibrations, so maybe you need more screws here to keep everything and the PCBA and everything in place, right? It's just an
Yeah.
example, right? Once you really understand how it's going to be used, what environment, what special cases, what stresses can be expected, then it's important to also have a review. However, okay, most manufacturers don't really review for reliability. That's not really their job. Reliability is really more about the product design than the manufacturing of the product, right? So that's typically, I
Mm.
would advise people to design for reliability and get some reviews about reliability early on. First prototype, second prototype, look at it and confirm it's all good, right? So that's anyway, my long explanation about why it's so important to actually get a review of the design files and everything.
Mm,
And if it's a good manufacturer that is used to doing that, then they can provide a lot of value, and it's really a must.
mm,
You can't skip that.
mm. Yeah, we've said it before for sure, but it's worth repeating. And, you know, this is the bad practice, right? Throwing the product drawings over the wall means
Hmm.
not going through that review. And that's been so detailed, and you haven't even included everything. So it just shows
Mm.
how much dialogue is needed. What if you do give a manufacturer, your prototype, maybe some product designs,
Mm.
and just say to them, okay, guys, go ahead. I mean, would it potentially be that they sort of wrestle with it for a while and then eventually they come back and say, we just can't make it, so you've wasted a lot of time and money? Or do you wind up with a product that is, nothing like what you would expect, and then everybody's really disappointed?
It could be a lot of things. I mean, recently I talked to a company that picked very clearly the wrong manufacturer. They went to
Mm.
them and then they say, okay, this is our design, and then the manufacturer, what is their incentive is to go into mass production as fast as possible.
Oh
So
yeah.
they say, okay, well, we need to make the tooling. Okay, well, let's start making the tooling. Send the money. Here's the quote. Let's do it. Okay, no DFM made at all. But the problem is that the design drawings were not mature. So some of that tooling can be salvaged, and some of it has to be some of it has to be reworked with some minor changes, and some of it has to be basically scrapped. So that's a lot of
Mm.
money thrown down the drain, right? That's
Wow.
just one example. I mean, if it clearly cannot be made, they will tell you it cannot be made. But the problem is the later, that's important point right here, is that if you wait until you have the final working, work like and look like prototype and everything, and you send it to a manufacturer and okay, let's, do it. And then they tell you, well, it can't be made that way. Then you have to go back to design files. But
Mm.
if you had known about that 3 months earlier, you would have done the redesign at that point. And maybe there's a lot of other things that are relying on that part of the design. So if you need to redesign one module of the product, it might have a lot of other consequences, right? So the earlier you know
Yeah.
it, the better. And that's why if you count on the manufacturing to do a DFM review, well, you need to start the handover before you think that the product design is frozen and everything is good.
Right. Okay. Yeah, that's a good point there. Okay, good. So that's the sort of bad of it, right? Now
Mm,
let's look at the good practice. So you've
mm,
got kind of a list of points that everybody should keep in mind when actually going through the handover process, right?
mhm. Right. So yeah, I'm going to go through a few points one by one. And the first one is
Hmm.
obviously before you actually hand over to a manufacturer, you need to select the manufacturer, right? So maybe
Hmm.
you already have another product that's in the same space and so on, and you already work with a good manufacturer. Okay, well, talk to them about the new one, and if they've been doing a good job, um, keep going with the same one, right? That makes sense. Now, if you're not in that situation, you need to go out there and find a new supplier, right? So uh, again, I refer to a past episode about the different kinds of suppliers, contract manufacturer versus ODM versus ODM.
Hmm.
If you've been developing your own product from scratch, well, obviously it's not going to be ODM because ODM means that the product design is based on the supplier's existing products. Um, uh, OEM, that's when the supplier will do some of the design, but they will kind of take ownership of some of it. It's really not usually something we suggest. So if you want control of over your product design and your project in general, you want to go with a CM, right? Contract manufacturer. Okay. And contract manufacturer, so you you can look for contract manufacturers, you can talk to them, you can see which ones have the right kind of expertise and experience. If you make, I don't know, if you make drones, well, you don't go to a contract manufacturer that's specialized in, I don't know, kitchen equipment, right? For example, or if your product has a relatively advanced camera module that you've been already working with a camera manufacturer or maybe a display manufacturer or something complex where you've already been tweaking an existing design and it's going to be a key module of your product, then you want a contract manufacturer also that has some experience around that because they will
Mm.
also have to understand how to integrate it with the rest of the product, but also how to test it, right? For example, and you would need them because probably they're in the same country, right? As that
Mm.
module supplier, specialized module supplier, you would need them to do the work of coordinating things and so on, right? So it's better if they are in the same space, let's say. And
Mm.
some contract manufacturers deal with a lot of, a very wide range of products. That's fine. Just make sure that they understand the main technologies and the main manufacturing processes, right? That's really the key. Ask for, how they work. Ask to see if, when it comes to the main terms of the contract, everything is aligned and
Mm.
everything, right? See if communication is easy. See if they have a structured process for new product introduction
Mm.
versus they usually count on their supply on their customers to provide the structure. Or in that case, if they don't have internally the right validation processes, the right gates, okay, we don't go into tooling before we have done DFM, for example, right? Well, that's where really you expose yourself to all kinds of issues. Okay, so first you select a manufacturer, right? And they are going to be your main supplier, meaning that, okay, hopefully they also provide you for some transparency, right? You're not going to be left totally in the dark when it comes to what component suppliers are used and so on and so forth. So they are going to orchestrate and coordinate the rest of the supply chain. And you want to make sure you're not sort of hooked in, right? Oh, there's some tooling made, you have a contract that actually says you can pull the tooling at any time, and that contract is enforceable, in the country where they're located. This is the kind of things that's really, really important. Okay, so then you need to tell them, you need to start to actually hand over the information. And chances are there's a lot of history, and it's not so easy to actually to give the full picture of it in a 1 hour call, right? So try to provide a brief, okay, a high level brief. Okay, this is the kind of product. It aims at solving this kind of problem or providing this kind of value. It's for this kind of user. It's going to be used like this. Maybe you shoot a video of here's the main parts, here's how it comes together, here's how the product works, here's from the user perspective how it works. Put together a first draft of the user manual. Okay, the user is going to do this, then it's going to do this, then this will happen. The main flow of the features, let's say, because this is really important. It's also dictates how the product will be evaluated, will be tested, function tested, right? You've picked some components and materials and everything. Well, then you should have an initial bill of material, right? An engineering BOM that at least provides a list of components, right? So there's one part that's going to be the top of the housing, and there's this part that's going to be whatever, a button, etc., etc. And maybe you link to the exact model that you used, if it's standard off the shelf or if it's if it's customized, custom designed. Okay, then you need to provide the mechanical drawings, and it should all be numbered, so it's easy for people to see. Okay, from element number 12 on the BOM is this part. this part of the mechanical drawing, right? Um,
Mm.
Also, things like what are the critical performance targets, what's really, really important that these products, it has to do that. So, um, for example, we've been doing some work on like electrical skateboards, right? So electrical skateboard,
Hmm.
it's got to go up to that speed within that many seconds with a person who is that heavy. These kind of things, you need to start to translate it. Okay, this is what the user is going to see, but then as much as possible, you translate it in engineering speak, Okay, that means whatever the motor has to provide that much torque, or the acceleration has to be that fast. These types of things, because this will have to be tested and validated, right? The expected quality level. Now, people, I stopped counting how many times people say, "Well, just look at the iPhone; it's really nice, and we
Ah,
need the same, the
right.
same finish." Well, okay, we already talked about that on the podcast, right?
Yeah.
It's kind of funny. So, no, let's be realistic, right? Try to communicate that in a realistic manner. Be realistic, right? Also, the reliability target, right? Like, who's going to plan for the reliability testing and everything? If you do it on your side, okay, it's still good for the manufacturer to know about that, because as they're going to work on maybe picking some of the suppliers, are they going to pick some of the active components that are rated for whatever, 1,000 cycles versus 10,000 cycles?
Mm.
It depends on your reliability target. And if you don't have any idea about that, at least you should tell them, well, typical user is going to use it, once a day, and I want it to work, at least 2 years, and we're going to have a 1 year warranty, but really it should work, 2 years with a relatively high confidence level. Okay, that's already a target. It's not great, but it's already a starting point, and people can calculate based on that and say, okay, how many cycles, and you say once a day, but for how long? People can refine that. Okay, so you start to pass the information over to them, right? And then you need to see, okay, where can they be better than our team? Because remember, you're not doing that at the very, very end. Like, okay, we have a final prototype, everything is perfect. No,
Mm.
maybe you need to, you have a module that's a bit too large. You need to miniaturize it, and you need to source maybe a new motor or a new battery or something. Okay, maybe they would do that better than you, because maybe their
Mm.
sourcing and purchasing people are right there in the country, and they already have experience with these kind of components, and maybe your team is not. So maybe it's better if you start to rely on them. And typically, like what we do usually is we say, okay, give us the BOM, and then, okay, what's the prices for every line on the bill of material? And we say, well, this one is very expensive. This doesn't make sense. And they're like, yeah, right, this is kind of a problem. Okay, well,
Mm.
we need to work on that. We need to challenge it. We need to see if we can find a supplier that's going to be maybe half the price, right?
Mm.
Sometimes really, again, engineering designers, what they do is they want to put the prototype together in a way that it works. Okay. They are not trying to fine tune everything. They don't have time. They don't have the bandwidth to optimize it for every important dimension, right? They have to get it to work. They have one or two challenges in their minds. They have some unknowns. They put things together. They're happy if it works. All right. Next design iteration, what are the main challenges that we need to tackle? They can't
Mm.
have everything in their mind usually. So we find a lot of low-hanging fruits to work on usually, right? So bottom line is start to rely on the contract manufacturer. There's certain things that they might be able to do faster than your team, better than your team, or maybe your team is already fully busy. Well,
Yeah.
then it's extra resources to go faster, right?
Mm.
Okay, then I talked about the bill of material, maybe mechanical drawings. yeah, DFM review, okay, and then who's going to make the adjustments? Again, do you need them to be a resource for you, or do you need to do you want the same team that did the engineering design to make the adjustments, right? But and usually both can be fine. And start to work on the costing. Maybe yeah, for the custom design parts. Well, how much is tooling going to cost? And based on the consumption of material, etc., what's the production unit going to cost, right? Also, for the mechanical drawings, very often they send a 3D drawing that was used for 3D printing and things like that. Well,
Mm,
okay, that's nice, but we also need 2D drawings, right? The 2D drawings will show the dimensions, the tolerances. It should include clear mentions of the uh, color, material, finish, these very important things, right? And also, sometimes they come up with a lot of dimensions and tolerances and everything. Okay, first, do the tolerances actually make sense, right? But also, you give us a drawing with like 20 measurement points. Okay, which ones are critical?
mm,
Which ones are less critical, meaning that in production we won't need to check every single one of them. Like as long as this part fits with this part, we're okay. Okay, then we don't need to take the caliper out every time, right? Or to make some kind of checking fixture or something. So mechanical drawings, how mature are they, and who is going to work on putting together the 2D drawings and so on, right? Electronic design, embedded software, right? Okay, how mature is that? Are they happy with all the components? Do some of the components actually need to be purchased now because maybe they have a long lead time, right? So these are the types of questions that need to be asked, right?
mm,
And sometimes, oh yeah, right, we still have an issue with this or that. Okay, well, please see if you can source that component. Please see if you can redesign that PCBA. These types of things. Sometimes that gets done by the manufacturer's team. Okay. Then what we usually suggest is that the final prototype, once it looks like, okay, well, all the main issues seems like they've been solved, sort of on paper. Okay, who's going to validate that? Like, don't go into tooling before validating that, and you need to put together a prototype and test the prototype, right? But who's going to put together that prototype? Ideally, it will be the manufacturer, because
mm,
by putting together the prototype, the manufacturer will learn how assembly gets done. They will see if some operations are a bit tricky, right? They will be able to provide suggestions, and sometimes the suggestions just take, maybe there's 1 week turnaround for a small change from this to that, and different way of fixing that part of something. Okay, done.
mm,
Well, that's better. And based on that, the manufacturer will be much more likely to provide a relatively accurate quote for the assembly, packing, testing work, right? Because
mm.
now they know exactly what it takes, right? They maybe they take a video when they assemble the prototype, right? That's just an example. Okay, and then you have the hardware, you have the software. Maybe um, if the manufacturer already started to do some of the design work to finalize the product design, maybe as the software is handled by someone for the customer, it has to be integrated. And sometimes the integration and the testing and the fine tuning and everything takes days, right? So you got to plan for that also. Ideally, you start to integrate earlier and then you see what the issues are, etc. But if you have like two totally separate teams working on these things, the
Mm,
integration might not be smooth. We've had cases where it took more than a week, and that's very time intensive because the people have to be on a call, for hours and try things together, and one provides feedback to the other, and they're doing some adjustments and try again, and oh, let's try to debug, let's try to see where the issue is, and so on and so forth. So
Mm.
these are some of the typical issues. Okay, then, well, once it goes into tooling, once what they call EVT, engineering validation testing, is completed, is really validated, the product design is frozen, it works as intended. Okay, let's go into fabricating the tooling and getting the design. It's called DVT, design validation testing. Let's get the tooling made for the custom design parts. And once we have the parts coming off of tooling that are validated aesthetically and dimensionally, okay, let's put some tooling samples together. It's just prototypes again, maybe 10 pieces or maybe 20 pieces. Okay, put them together, test again, but also sometimes if the aesthetic requirements are relatively high, that phase can include a lot of trial and error. But by that time, the manufacturer should be in the driver's seat and the customer should be providing feedback. So the handover is basically done. I mean, the industrial designer ideally is still involved and still providing guidance and feedback, right? So it's still, you might say, it's still sort of the end of the handover, right? Of all the information about how the product should look, should feel, it's got to sound that way when I drop it on the table. It's got to do a nice thud, oh, it's got to feel heavy. That will feel like a higher quality product. That's the finalizing the handover, right? Then the manufacturers get to work on getting it right, or at least getting it to a point where the industrial designer is happy enough, right? But then you have to deal with the limitations of the technology, that the manufacturing processes, the whatever, the surface finishing that was picked and so on, right? Sometimes miracles cannot be made, right? And people have to compromise and okay, let's go ahead for version 1. This is good enough, right? But also this is the time when the golden samples are approved. Ideally, the limit samples also to set the boundaries of what is or is not acceptable. And this is really helpful to provide the manufacturer with the acceptance criteria, right? It's really, really important. So I think I haven't forgotten anything important here.
Okay. Well, that's a lot to take in, but that just goes to show what is involved in handing over the manufacturing to your manufacturer in order to get a good result, basically, isn't it? So
Right.
there's plenty to think about, but it shows there's such a stark difference between that and, hey, I've got my product design, I've got, maybe a prototype. Here you go, guys, crack on. You get that going. Show me some products ASAP. It's a huge difference. And by missing this, I mean, wow, the risks are incredible. So I think that's very, very helpful today, Renaud. And so many related pieces of content to include in the show notes. So as I always do, please check those. There'll be some links to go further. And I think we can call it close to this episode. But yeah, thanks for being with me. Speak to you next week.
All right. Thanks, Adrian. Yeah. Thanks to the listeners, and you will hear from us next week as usual.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.